Today we are going to discuss problem number 41, which is from today's class onwards. We will be discussing the recently concluded IIT Advanced paper problems. So I have selected this question on collisions first. Statement is there, a simplified statement I have given. The larger mass 2m is colliding with a smaller mass m, which is initially at rest. Larger mass is moving with some velocity. I am taking that velocity as u. So after collision, the two particles move in two different directions. So maximum angle theta of the deviation of the heavier particle is required. Maximum angular deviation. Now, in this type of question, first, if there is a line of center at the time of collision, if the line of center is same as the original direction of motion of the particle, moving particle, then both particles will move in the same straight line only, forward or backward, same straight line. Whereas when angles are, when there is some sort of deviation is there, means this is not the line of center. So I have redrawn the diagram below. Above the green line, you see what is the data given. Here I have redrawn the diagram showing the line of centers at the time of collision. Time of collision, line of center is different from the original direction. So there is a deviation for the colliding particle, there is a deviation. The other particle which was at rest will move along the line of centers. There is no other option because that is the line, that is the direction of collision. So it will go in the line of centers. So I have marked the angle of the smaller particle as alpha from the original direction. So that will be the line of center also. So this also, both are alpha. Theta is what we want to maximize. So I am taking the line of center as x-axis, normal direction as y-axis, which I have marked. Okay. I will use the conventional method of momentum and Newton's equation concept for this. So momentum equation we shall write in the x-axis. Momentum equation, initial momentum equals final momentum. So momentum equations x-axis, x along the x direction, 2mu cos alpha, the momentum 2mu cos alpha along the line of center. Line of center is the x-axis. So 2mu cos alpha is equal to final momentum is this 2mv1 cos theta plus alpha. 2mv1 cos theta plus alpha. Then plus mv2. Whatever I have marked in red are our assumed symbols. The data symbols are given in the first diagram. Okay. 2mu, 2mv1 cos. Now in the y direction also there is a momentum, initial momentum due to the striking particle, that is y-axis 2mu sin alpha. 2mu sin alpha. Initial momentum along the y direction. Final momentum, the smaller particle has no momentum in the y direction finally. So only this 2m. 2m v1 sin theta. 2m v1 sin, to this y-axis the angle made is this angle at right angle is theta plus alpha. So sin theta plus alpha. So that and that I am taking is so actually 2m you can cancel mass because only one mass is involved. So 2m you can cancel. So this I am taking as equation 1. Equation 1 also I will simplify. I will simplify the equation 1 with the masses cancelled, m cancelled. So that will be 2u cos alpha equals 2u cos alpha equal to 2v1 cos theta plus alpha plus v2. This I will take it as equation 1. Then this one is equation 2. Equation 2 we are taking. Now the Newton's equation. Newton's equation is velocity of separation equals E times velocity of approach. Here E is perfectly elastic collision, means E is equal to 1. So Newton's equation is velocity of separation is this v2 minus in the direction of collision, that is along the line of centers we have to apply that. So that will be v2 minus v1 cos theta plus 1 cos theta plus alpha is equal to E times velocity approach is u cos alpha. So that is u cos alpha where E is equal to 1. E equals 1. So that is our equation 3. Call it our equation 3 also, I will rewrite it. That is the Newton's equation, v2 minus v1 cos theta plus alpha is equal to u cos alpha. Equation 3. Now we write 1 minus 3. Equation 1 minus 3 gives us, implies 3v1 cos theta plus alpha is equal to u cos alpha. Which is equation, call it as equation 4. Now we divide v1, our earlier equation, the second equation was v1 cos theta sin theta plus alpha equals u sin alpha. This was our equation 2. I am repeating that so that I am going to divide the two equations. 2 divided by 3. The third equation is, so when you divide, you get 2 divided by 4. 2 divided by 4 gives us, implies tan theta plus alpha, divided by 3 is equal to tan alpha. So tan alpha implies 3 tan alpha is equal to 3 tan alpha equals tan theta plus alpha I will expand, tan theta plus tan alpha by 1 minus tan theta tan alpha. Tan alpha. So that on further cross multiplication we get 2 tan alpha minus 3 tan theta tan square alpha is equal to tan theta plus tan equal to tan theta. because I have also simplified 3 tan alpha here and this tan alpha I made it to 2 tan alpha minus 3 tan theta tan square alpha equal to tan theta. So this is our useful step. This is a useful step. From this only we are going to minimize the required maximum angular deviation we are going to get, because this is a relation between theta and alpha. So theta maximum implies d theta by d alpha must be 0. That is our calculus I am using, equal to 0. So we work out d theta by d alpha equal to 0, we work out. So I will further continue this after clearing some more space. Okay. So the last expression we differentiate with respect to alpha. So d theta by d alpha, we differentiate. Wherever d theta by d alpha comes, we take it as 0. So we get this 2 secant square alpha minus 3 tan theta into 2 tan alpha secant square alpha becomes 0. Because wherever d theta by d alpha comes, we can neglect it, because that is going to be 0. So from this, what you get is 3, okay, secant square alpha you can cancel. So 3 tan theta tan alpha becomes equal to 1, because these 2 also cancels. 3 tan theta tan alpha becomes equal to 1, or tan alpha is equal to tan alpha equals 1 by 3 tan theta. 3 tan theta. Now we substitute in the original equation our previous equation where theta and alpha are involved. This implies 2 times 1 by 3 tan theta minus 3 tan theta to 3 tan theta into 1 by tan alpha square is involved, so that will be 9 tan square theta. Is equal to tan theta. So we simplify this. This also you can easily 1 by 3 tan theta. 1 by 3 tan theta, if you take as a common factor, we get, this implies 2 minus 1 is equal to 3 tan square theta. 3 tan square theta. Which implies tan square theta equal to 1. Tan square theta is equal to 1 by 3. 1 by 3, or tan theta equals 1 by root 3. 1 by root 3 implies theta equal to 30 degrees. This is the required answer in degrees, or pi by 6. Pi by 6 is the quoted answer in the question, so we get pi by 6 as the answer. Now this question you can also suppose as an objective question. This full work, the working is not at all required. If you know the formula for this type of question, you can simply substitute in the formula and get the answer. So I will quote the formula for you. As a note, just quote the formula, just take note of the formula. Okay. Note or formula. We mark the larger mass as capital M, small mass as small m, as it is. So formula says theta maximum is equal to theta maximum for this type of question. That is, the larger mass must be moving and colliding with a smaller mass at rest. So theta maximum is given by theta maximum is equal to sine inverse of m by n, small m by capital M. That is our formula. So if you remember this formula because this must have been discussed in your class, if you remember this formula, just m, this capital M is equal to 2m according to data. So you get theta maximum is equal to sine inverse half, which is also theta equal to pi by 6. So with just 5 or 6 seconds you can get the 3 or 4 seconds you can get the answer, whereas if you work the full allowed time is only 3 or 4 minutes, but that within 3 or 4 seconds itself you can get the answer if you remember this formula, which must have been discussed in your class. I think you understood the concept. Thank you. Dear students, in our next video also, I will appear with the solution to another problem from the same IIT-JEE Advanced paper 2025. This we will continue for the next few classes, next few videos. We will continue the same procedure. Okay, thank you.